How does rectification work in electrical engineering? Imagine you have a wave that goes up and down, like a roller coaster. Now, think about turning that wave into a straight line that always moves in one direction. That's what rectification does in electronics. It takes alternating current, which flows back and forth, and converts it into direct current, which flows steadily in one direction. This process is super important because most electronic devices need a steady supply of direct current to work properly. Power from the electrical grid is alternating current, so we use rectifiers to change it into direct current for our gadgets, batteries, and circuits. The key player in this process is the diode, a tiny semiconductor device. Diodes act like one-way valves for electricity. They let current flow easily in one direction, called forward bias, but block it when the current tries to go the other way, called reverse bias. This property is what makes diodes perfect for converting AC into DC. When AC comes in, the diode only allows the positive parts of the wave to pass through, blocking the negative parts. This creates a pulsating flow that is unidirectional but not perfectly smooth. There are two main ways to do rectification. The first is half-wave rectification, which uses just one diode. It allows only the positive half of the AC wave to pass, while blocking the negative half. The output is a series of pulses that go in one direction, but it's not very efficient because half of the input is wasted. The second method is full-wave rectification, which uses either two diodes with a center-tap transformer or for diodes arranged in a bridge configuration. This setup makes use of both halves of the AC wave, doubling the output frequency and making the flow smoother. Full-wave rectification produces a higher average voltage and less ripple, which means less fluctuation in the output. The pulsating DC from the rectifier isn't perfect for most uses. To make it smoother, we add filtering components like capacitors and inductors. Capacitors store charge and fill in the gaps between pulses, reducing the ripple. Inductors can also smooth out the current flow. This filtering turns the pulsating DC into a more stable, steady voltage that electronic circuits need. Understanding how diodes work and how to arrange them in circuits is essential for designing effective rectifiers. Engineers consider factors like load requirements, power ratings, and efficiency when choosing the right rectification method. These circuits are used everywhere, from power supplies for computers and chargers to radio receivers and embedded systems in appliances. The choice between half-wave and full-wave rectification depends on how clean and stable the output needs to be, as well as cost and complexity. In essence, rectification is all about controlling the flow of current using diodes so that the bidirectional AC gets turned into a unidirectional flow. This process makes it possible to power our electronic devices safely and reliably. The simple yet clever use of diodes in circuits allows us to convert and control electrical energy in countless applications, making modern electronics possible.